Imagine you are designing an electronic circuit and need a component to quickly turn power on and off. You are faced with two common choices, each with unique strengths. Making the right selection here is crucial, as it directly impacts your circuit's performance, efficiency, and overall complexity. Understanding the fundamental differences allows you to engineer optimal solutions. Engineers should generally choose a metal oxide semiconductor field effect transistor, or MOSFET, over a bipolar junction transistor, or BJT, for switching applications when high speed, low power loss during conduction, and simple voltage control are paramount. Conversely, BJTs might be favored for very high current or high voltage applications where cost sensitivity or specific ruggedness characteristics outweigh other considerations, especially at lower switching frequencies. The core difference lies in their operational principles. A MOSFET is a voltage-controlled device, meaning a voltage applied to its gate terminal creates an electric field that opens or closes the current path between its drain and source. Because it relies on the movement of majority carriers, MOSFETs can switch very quickly. In contrast, a BJT is a current-controlled device, requiring a continuous current flowing into its base terminal to allow a much larger current to flow between its collector and emitter. BJTs utilize both majority and minority carriers, which means they store charge and take longer to turn off, limiting their high-frequency performance. To make an informed decision, consider several practical factors. If your application demands rapid switching speeds, such as in switch-mode power supplies or high-frequency inverters, the MOSFET's quick turn-on and turn-off times make it the superior choice. For minimal power dissipation, when the switch is fully on, choose a MOSFET due to its extremely low on-state resistance, often referred to as RDS on. This characteristic significantly reduces conduction losses, especially important in battery-powered devices. If your control signal is a voltage from a microcontroller, a MOSFET integrates more easily, whereas a BJT would requiring additional current-limiting resistors or driver circuits. A key internal detail for MOSFETs is their gate capacitance. While beneficial for voltage control, charging and discharging this capacitance quickly requires a dedicated gate driver for very high-speed applications. For BJTs, maintaining saturation requires a sufficient base current drive, usually a tenth of the collector current, to minimize the collector-emitter saturation voltage, or VCE-SAT. Understanding these parameters, RDS on versus VCE-SAT, is fundamental to predicting power loss and selecting the most efficient switch for your design. Ultimately, the selection between a MOSFET and a BJT for switching boils down to a thoughtful evaluation of your circuit's specific needs. By appreciating the voltage control and rapid, low-loss operation of a MOSFET against the current control, and sometimes more robust, but slower, characteristics of a BJT, you can design circuits that are not only functional but also highly optimized for efficiency, speed, and cost, ensuring reliable performance in your electronic systems.